Hi guys, so we are back with the second session, I guess you want to say, of solving exponential and logarithmic equations. So here we go. We have a few definitions to go through first. First, we're going to define a common logarithm. Common logarithm is a logarithm, a logarithm with the base 10. Oh, to the base of 10. And it's commonly written, an example would be log of 1,000. So if you see a log without a base, it's always going to be base 10, just so you know, so this would mean log base 10 of 1,000, which we know equals 3, because 10 to the third power is 1,000. So anytime you see a log without a base, it's base 10. They just don't put base 10 because they just assume that you guys know that, now you guys know, but they're going to assume that you know that if it doesn't have a base, it's base 10. Please remember that. If it does not have a base, it's base 10. So that's our definition of a common logarithm. The next is a natural logarithm, and that's a logarithm of course I spelled logarithm wrong. Logarithm to the base of e. So an example would be the natural log, and yeah, I know it should be in L, but they still wanted to start with an L, so it's ln, natural log of 7.389, which equals the log base e of 7.389, which is approximately 2. So so you guys know, if you see natural log of e, log base e, it's just natural log. That's how it's written. So if you find something when we're rewriting things, especially an exponent to a logarithm, and you get log base e, we just replace that log base e with natural log. That's the nice clean version. And yes, there is a natural log button on your calculator. You can go look. It's right there. It says ln, and it should be around the log button. So I hope that helps with that, if you see that. And then our last definition for this lesson, for this section, is the principle of logarithmic equality. So that's it's very similar to the one for exponential equality. This says for any logarithmic base a. So for any logarithmic base a, for x and y greater than 0, x equals y is equivalent to log base a of x equals log base a of y. So similar to the exponential equation, if my bases are the same, so I have base A, and I have one log on each side with the same base, in order for it to be equal to each other, I just set the two pieces, the x and the y, equal to each other and solve. So whatever this piece is and whatever this piece is, I set equal to and solve, as long as there's a log on both sides. So we're going to work through problems that would involve all of these. The first set we're going to work through is notice that they're all in exponential form. So if I can't solve it as an exponential, the rule is I'm going to switch to a logarithmic to solve, kind of like we did on that last problem up there. So here we go. Before I can switch it to a logarithm though, however, I have to make sure that the part with the exponent, which would be this part right here, is all alone. It has to be by itself. So how do I get that by itself? Well, it says 9 times 20 to the 7b power. So how do I undo times? Well, I'm going to divide by 9. So then I'm going to have 20 to the 7b equals 95 over 9, because 9 doesn't go into 95. So I'm just going to leave it like that. Is that okay? Yeah. Yes, that's okay. It's all right. So we're going to go ahead and switch it to a logarithm now. Okay, so here we go. So I get log base 20 of 95 divided by 9 equals 7b. Okay, so now I could put this into my calculator right now if I chose to, but then I'm going to round here, and then when I divide by 7 again, I'm going to round again. So that's rounding too many times. I just want to round one time. Okay, so I'm going to solve for b first before I put the whole thing into the calculator. So what I'm going to do to get b by itself again is I'm going to divide by 7. So I'm going to divide this whole thing by 7. So b is approximately going to be equal to, now what I'm going to do is I am going to put this whole thing right here into my calculator, just like this. And I'm going to say that you probably need to put this part before you put it into the calculator into parentheses. So I'm going to do parentheses log base 20 of 95 divided by 9, and this, just so you know, will also be in parentheses. Okay, so you'll have double parentheses at the end, and then divide that whole thing by 7. And you should get approximately equal to, and we're going to round to 4 decimal places. Okay, 4 decimal places. So b is going to be approximately equal to 0.1124. Okay, so there's my answer for that problem. Again, Desmos does the logs with the basis. So if you have that on your phone, or you can also get the Desmos calculator on the computer, that will work also. You just go to Desmos, I believe it's desmos.com, and the graphing calculator, and you can type it all into there. And remember, to get to the log function, you're going to go to functions and go to miscellaneous, and it will be over there. So now we're going to go on to the next problem. I'm going to kind of move over and zoom in here. So I'm going to zoom in a little bit. So again, I want to get the exponent. So I want to get this piece by itself, yeah? So what do I need to do first to get that by itself? Well, I'm going to divide by 2. Great. So then I get 10 to the x minus 1 equals 99 divided by 2. Okay, now I'm going to switch it to a logarithm. So then I get log base 10 of 99 divided by 2 equals x minus 1. And then to get the x by itself, I'm going to add 1 to the others, to both sides. And I want to say this here. I'm going to change my highlighter color. So this piece right here is one number. I'm not adding 1 to the 99 halves. This is a whole piece. This, the log base 10 of 99 divided by 2 is one number. So I can't add 1 to the 99 divided by 2. So this becomes x equals 1 plus log base 10 of 99 divided by 2. Okay, so you need to make sure that you're adding 1 to this whole number here. This is a number. I can't add 1 to the inside of it because you will not get the same answer. Okay, so x is approximately equal to 2.6946. When we say 4 decimal places, that's 4 numbers after the decimal. Okay, so last problem, here we go. We're going to do the same thing. Again, I need to make sure that I get the exponent, or the number with the exponent, or whatever has the exponent by itself before I switch to an exponential. So the first thing I want to do is subtract 8. So I'm going to subtract 8 first. So I get e to the x plus 7.2 equals 21. Now I can switch to a logarithm. So I get log base e of 21 equals x plus 7.2. And then I'm going to subtract 7.2. Okay, so I've got x equals the natural log of 21 minus 7.2. And I'm just going to put that into my calculator, right? So again, x is going to be approximately equal to, and you have a natural log button on your calculator. So I do natural log of 21, make sure the 21's closed in the parenthesis, and then minus 7.2, and you should get minus 4.1555. Okay, so I'm going to go ahead and stop there and give you guys some problems to do, and then I will see you back in a few minutes. Talk to you soon. Bye.